Hello everybody, this video is going to be about bitmaps, and I'm going to be using this term and others very loosely, very broadly, as opposed to the specific definitions of what it means in a particular API or library or platform. So generally speaking, when somebody says a bitmap when it comes to computer graphics, what they're really actually talking about is just a two-dimensional grid of pixels. Now, what's a pixel? Pixel is some color, but is generally represented as just a collection of bits. Unfortunately, there isn't one standard way to represent it. Different platforms, different APIs, different file formats can represent a pixel in different ways. The two most common ones in terms of how many bits each pixel has is 24 and 32, and they're segregated to 3 or 4 channels in the case of 32-bit, where each of which is 8-bit, but it could be a lot more than 24-bit for high dynamic range and stuff like that. But this is like the most basic two representations. So each channel represents a certain light color, red, green, and blue, and then the combination of those can produce a pixel on the screen or in a bitmap, in a file that contains an image comprising of these two-dimensional pixel grids. Unfortunately, it gets more involved than that. There isn't one standard in regards to which of the color channels is first and how they correspond to which bits within the entire bit set of a pixel. So sometimes it could be red, green, and blue. And in the 32-bit case, there's an alpha channel, which is another color channel that just represents transparency usually, but sometimes it's just padding, so it's just ignored. So red, then green, then blue, but it could also be reversed, like blue and then green and then red. NDNS gets involved with that, and all kinds of stuff like that. And whether or not the alpha channel is at the end or the beginning can also change. And then on top of that, the ordering can also change. So the main point to keep in mind is that whatever format you're using for your solution, for your software, the way you read stuff from disk or from memory needs to be aware of those conventions or definitions, and there needs to be an awareness and synchronization between the format that contains the data versus the way it's being consumed and interpreted. As long as there's synchronization between these two, it doesn't really matter. There isn't like one way that's better than the other. Anyway, so that's a pixel. So bitmap is just a 2D pixel grid. It can also be represented in memory as not just a 2D array like a nested array, but just a 1D, one-dimensional array. In this case, these rectangles represent the actual pixels, not the bits within a pixel. So as you can see, they can correspond to their placement in the two-dimensional grid. There can be all kinds of bitmaps that have different names. What ends up happening is that bitmaps are such a the concept of a two-dimensional grid is such a ubiquitous construct that can be used for so many different things that they started having different names and terms to refer to a particular usage of a bitmap for a particular purpose. Okay, so like a frame buffer, or sometimes called a render target, is the thing that you typically end up displaying on screen in a window, and textures or sometimes sprites um, are used to talk about some content that you're reading from a file or moving around in memory before it is displayed on screen. Okay, so how do we draw bitmaps? Sometimes that's called bleeding. It's just the process of copying the bits of the pixels from one bitmap to another, usually from one of the bitmaps that are of a type of a source, like a texture map or a sprite or a file, and usually copied for drawing. You copy it to a frame buffer or render target, something that is going to be displayed on screen, and that process can involve cropping and scaling, and or like taking from a specific offset, as we're going to see, and it can involve sampling, which we'll talk about, and filtering, which we'll talk about. So what is sampling? And again, this definition using in a very broad and loose way. Again, different APIs, different libraries, different development environments may define terms to mean more specific things, and distribute the components of the semantics differently across the terms. But generally speaking, sampling is the for bitmaps is the process of getting a particular pixel color value out of a bitmap in some way. So like scaling up would be to use the same value that you get from the source pixel in the source bitmap and using it multiple times in the destination bitmap. And that's like a simple way to scale up. Scaling down can be like reading only every other frame or every nth every other pixel or every nth pixel, either horizontally or vertically or both, or with some kind of interleave pattern. Cropping or slicing, it just means that you can just take some subset of the source pixels of the source bitmap. So you can start with some offset and go up to some offset, either horizontally, vertically, or both, and then just get some subset rectangle within the source bitmap. And you can also map. Another way of sampling is to start with some abstract coordinate system representation, and with some scheme, which there could be different schemes, map that to coordinates that are in terms of pixels, because like the source coordinates, the thing you start off with may not be in terms of pixels. It can be just in terms of whatever other unit that is relevant in the domain that the application is coded in. But there's some scheme that ends up mapping to from that coordinate system to the coordinate system of pixels within the bitmap, within the two-dimensional grid, some two-dimensional coordinate. Filtering. So say we have some point in some abstract coordinate system, and we map it to that point within the pixel grid. Now that point may or may not be specifically exactly in the center of a pixel. So the question is like, what do we do then? So that's where filtering comes in, or it is one place where filtering comes in, which basically says, well, how exactly are we mapping from that point into a color value that we end up outputting out of that bitmap for a particular sample. Linear nearest neighbor filtering is the process of saying, hey, whichever pixel center is the closest to where we are, just get that value. So that's the cheapest and simplest, but it may not always look very good ultimately. Bilinear filtering is saying, well, we'll take that, but we'll also consider some surrounding pixels horizontally and vertically, and do like a weighted average depending on how close or far the neighboring pixels are to the point that we're sampling. And as you can see in these two cases, the output of this ends up being a bit lighter because there's a bunch of white pixels around it that get averaged into the output pixel color value. And there's other filtering which I won't go into, and just mentioning one of them. This could be a whole talk on itself. Trilinear is just bilinear plus averaging across MIP levels, which we won't go into. So like some kind of texturing story there. And there's others, filtering anisotropic, for doing like sampling for grazing angles. So looking at a bitmap from a grazing angle, there's all kinds of problems that come with it. So there's a filtering scheme that addresses that. Okay, another thing that's related to bitmap in terms of particularly for textures and sprites. So a texture map could be just a static image for a particular usage, and maybe we have a bunch of those and we don't want to shuffle around too many different files or too many data structures in memory, and we want to, especially if you want to use the hardware acceleration, moving these things around between the main memory of the machine and the memory of the graphics processor is expensive, and we want to basically minimize that, so we can pack a bunch of bitmaps into one, just putting them right next to each other, and have a larger single bitmap that includes pixels from multiple different source bitmaps. And then what we do, we can sample, which can involve some kind of cropping, of taking some subset of the source source bitmap, and then maybe scaling them with one of the ways that we showed, and then just drawing the information that we got out of that into some destination place, in some destination bitmap, usually a frame buffer or render target. And then, like, if we want to get a different image that is stored within that that sheet, is called a texture sheet or a sprite sheet or atlas. So we know which image is stored at which offset into that. So we can just start reading from a different offset, and then we can get basically the pixels of the image that we're after from that atlas, and we can do that in both axes, and then we can get that different pictures. Another way to use that scheme is for animation. So say we have, in this case, some chicken, and there's like different frames across time that we want to display. So we can store them all together in like a single line, and maybe we store different animations in different lines like that. and then we just query with the specific offset which represent a specific frame. And then we can start offsetting it, and if we do it pretty quickly, it looks like an animation. Lastly, the same scheme can be used for drawing text. This is using something called bitmap font. So it's a font that has the glyphs represented as just pixels, as opposed to vector representation of them. And of course, every glyph, or every letter, or every number is stored at a different offset within that atlas. And then we can draw text just with using different offsets. That's it. Hope you enjoyed it. If you liked the video, you can hit the like button. If you want to be notified for further videos like that, you can subscribe to the channel. That's it. Thank you. Bye.